everybody. Welcome back to another episode of The Skeleton Crew. I'm your host, Jenn Callahan, and today I have three great guests with me today. They are joining me from the company Inner, and they're going to be talking to us about their company that does using CT and X-ray technology to look at electric vehicles and the batteries that are within them. So Efrat, Hans, and Mark are with me today from Amsterdam. Am I correct?
From Eindhoven, even in the Netherlands, but Eindhoven, that's the deep tech capital, I think, of the Netherlands.
All right. So thank you for joining me from, halfway around the world. I really do appreciate it. I'll allow you guys to introduce yourself, and maybe you can give us just a little bit of a background about each of you and how the three of you came together to create this company.
Sure. So maybe I'll jump in. So my name is Efrat Avnet Steinberg. I'm actually the only non-techie co-founder. I was a lawyer many years ago, and then a business developer in actually working in large corporates, but always on the non-core, always excited about starting something new, bringing ideas from seed to implementation to execution. And this is what we're doing here. Yeah, so worked in different industries, and in the past 7 years working closely with startups. And Inner is the startup that I'm busy with in the last 2 years. Yeah, so that's me.
Thanks, Efrat. How about you, Hans? What's your portion in the company of Inner?
Okay, so I'm Hans Burrman, CTO, a big word. Mainly a technical person, background in applied physics, pattern recognition. Then spent 25 years in the medical imaging industry here in the Eindhoven area. There's one of the bigger players, as you may know. I've probably helped design one of the systems that you've worked with. So the X-ray and MRI there. I've also worked on other stuff, all about taking innovation to products. So it could be in research, it could be product development and everything in between. And then I spent 6 years at the Dutch Cancer Registry, building the products that are a research institution, building a team there. And then it was time to look for something new, and I came across Efrat, and she had a proposition in X-ray, and I thought, no, that might be interesting. So I don't need here now.
Nice. And Mark, how about you?
Hi.
Background.
I still live on the south coast of England, but I'm in and out of Eindhoven often until we get ourselves fully established. I have an IT background, so claim to fame is operating systems. So big operating systems. Cut my teeth a long time ago and spent a lot of time with the big companies when they moved into operating systems. Starting my own companies, gosh, a long time ago. Helping people like Sun Microcomputers, HP. Then moved into the similar hands, moved into oncology. So mainly in radiation systems, because all the people were buying radiation systems, Linacs, they're called, using photons as in singular. So we set up in about 2010 the first ever joined up network for photon systems, and managed to make the UK private network. We did all the UK private photon systems around the UK. Then moved into protons and built the world's only joined up network of proton solutions, all for cancer treatment. And where my expertise was obviously networks and real-time computing. And then bumped into Efrat about a year ago. And we all got on until Hans turned up. I was the clever one. Now Hans is the super clever one. So he supersedes me. And we all get on really well. And, we're pushing really hard. I mean, the solution is just fantastic.
So how did this idea, between the three of you come together that this is, the direction that you were going to start up on?
I guess we were looking at, Efrat approached us, and the thing that excited me, and I think it excited Hans when we first started, was the ability to do a mammogram. Because obviously had a wife that died of cancer, and her going through mammograms was obviously very painful. And of course they're flat, and you have to push your chest right hard up against it. And this technology is about to be curved. But having Hans coming from that sort of market, it is still doable, and it's on the very, very back burner. It would just take 10 to 15 years to get that type of product into a market, purely because of the regulations and the rules and everything else. And I think I'll hand over to Efrat, but I think it was you that actually came out with the better option.
Who did?
Efrat.
Okay.
We were just trying to, but maybe, let's take one step backwards to tell a little bit about our technology, or maybe you would want to talk about it.
Well, okay. So Our technology is an X-ray detector, the special one. You know, X-ray detectors, of course, and the small ones and there are intermediate ones in the world. The technology we have allows you to build a modular one. So it's like Lego box. So you can build one that's small and you can build one that's really very large. And that sort of got us thinking that there's nobody out there that can really do a really large detector that can do that. Where is it useful for? Now, we looked at elephants in imaging like that, but there are not many places where they do elephants in volume. So then we came across another problem, which is batteries of cars. And of course, yeah, that's when you can apply yourself. If you want to look at something really big and you need to look through it, then a really large X-ray sector, a really large X-ray sensor comes in handy. And of course, this problem is quite for real.
Yeah, I don't know if you've, it was on the news in the last week or so that there's a huge crisis now in Korea, in Seoul. They had a huge event of fire in one of the parking lots. It sounds very random, but it actually, because this fire cannot be distinguished, it burns in 2000 degrees or something like this, then from a very local event of fire that you would call the fire brigade and just finish with that, it turned out to be a whole block fire with casualties. And this is from a Mercedes, from a new car, high quality car, but just, and those things keep on happening. And of course, the more you have EVs around you, there will happen more and more. And when we start using EV batteries for stationary application, which is also going to be very, very common around us for energy storage systems in the homes, in office buildings, then as long as those things happen, and once they start, they cannot, nobody can fight them, then the need for prevention and prediction really becomes a real issue. And this is where we can come in. Because if you look inside, and there, the analogy to the medical world that we started from in this conversation, and the one that's more common today, is really relevant. Because if you look inside, you can see it before it becomes a problem. And then you can take care of it. And this is exactly what we plan to introduce. Looking at the big object from the outside to see very tiny abnormalities before they grow and before it's too late.
So these abnormalities can happen even when they're, say, brand new batteries, that they've just been placed into the car. It's not technically that they're...
Absolutely. And they could be caused by many different reasons. Of course, quality control at the factory is normally pretty good, but it could be a little bit of dust that makes the cells touch each other and that causes it to heat up. It could be just a standard defect. It could be a small chemical reaction. It could be driving on a British road where there's more potholes than there is tarmac. And that will twist the battery frame. And so there's a million things to crash, overcharging. You run it a full charge to get this 10-minute charge. It obviously puts a lot of pressure on the chemical reactions than it does on a slow charge. So there's 1,000 reasons why it could go wrong. And it could go wrong from day one onwards.
Mm-hmm. And would they combust, say, is there just, like you said, there was a parking lot and the car was just sitting there, that it can combust, or could it possibly happen while the vehicle's moving?
There's a thing called a battery management system which keeps an eye on moving cars, and they're pretty good. And we complement them, we don't knock them out. And of course, they've got enough additional pieces of software and hardware to detect massive temperature changes, chemical changes. But often this happens very, very quickly. You only get a minute or two warning, and your Tesla or your BMW or whatever the car is, you'll get a warning come up and saying, look, evacuate the car. And you do get that minute or two. But you don't get 20 minutes or 2 hours or even 2 years, because our technology, in theory, will spot it very, very early on. And we'll have, as we grow the technology and make it better, we'll be able to give you insights and potentially analysis to say, well, this will go wrong in 6 months' time, 2 years' time.
Now, would you be scanning the vehicles, like, say, post-production as soon as they come off the line? Or when would this type of technology be utilized for the electric vehicles?
And I think at this stage, it will make very little difference. It's they have recalls, and it's post-production we feel that be the most likeliest scenarios.
And a couple of very clear scenarios that we can see today. One is, let's say, accidents. when the car has been in the crash, the rules of what you can do with it are quite strict. And you really want to know as soon as possible what's the status of the battery. And we heard at least anecdotal evidence. Sometimes the car looks perfectly fine, and then the battery is hurt. In other cases, the car really taken a severe blow, but the battery is quite all right. So this is a place where you want something like X-rating wheel to dig into it, see what's the status of the battery. Then there's another one that you can see in Second Life. So you have an electric car, and over time the capacity of your battery goes on, same with your laptop, same with your phone. And then at some point in time with your car, the capacity is not good enough. You want to be able to drive to grandmother and something can't reach her anymore. So then you have it swapped. But the battery is still perfectly okay. It just has 75% of its original capacity. I'm not sure what's like in the state, but here they're now pushing you towards having mobile storage. You have your solar panels on the roof, store the electricity that's generated there, use it at night or bad weather, and reuse it then. And these batteries are perfectly suited for that, as long as they're safe, because you're going to put them close to your house, and you want this to be safe.
I think it will, the most of the use cases, there will be certain junctions of decision making where the scanner would become very, very handy. So as Hans said, when you remove the pack from the car, because it doesn't have enough capacity to move your car, but it has enough capacity to light your house. That's one decision point where it's very, very handy. The second one is, Mark mentioned the recalls. There are around 100,000 cases of recalls of batteries from the top, the most well-known automakers, and those batteries are sent for dumping or recycling, and those are brand new ones. They've been on the road maybe a year. What a waste is that, right? And sometimes this is a physical damage, that they suspect is the issue, but they don't have the ability to look inside, right? Because is the anode torn? Is it separated, folded? They can't know. You cannot break a Tesla it has 9,000 cylinder cells the size of my finger. In order to check, you'd need to break it apart to those 9,000 cells and look at each and every one of them. You just don't do it. But we give you the access, right, to inside to really see what's going on there. So that's another example. Those recall packs, we can actually bring them back into the market. No need to replace them. And another use case would be you buy a 5-year-old EV. Today, you just you take it to the garage maybe to test the brakes. When you buy a used car, they test the brakes for you. They take the steering wheel, maybe the pollution. They give you a report, and then you take a decision. Am I going to buy it? I'm not going to buy it. So tomorrow, it's going to be they're taking a look at the pack for you and telling you, well, we actually see some cracks and swellings, and it wasn't treated well in the last 5 years. So maybe it's not the right pick for you. So we're giving you, so that's a third example of a decision point where this information becomes very handy and very useful for you as a consumer.
I'm not very well versed on electric vehicles, so I just was going to ask in terms, you said the battery's not good. Are batteries able to be switched out from electric vehicles?
I think that brings you to my point, which I'm about to say is the value of the car. Approximately half of it is the battery on electric vehicles. So when you're spending £30,000 or $30,000 on a car, 15,000 of that is now the battery. It's the footplate, so it's the whole of the underside of the car is the size of the battery approximately. And there's about 40 million electric vehicles already on the road. And if all projections and analysts are correct, by 2030 there'll be more electric cars than they will non-electric cars in the world.
Okay, wow, it's a lot. I know that the United States is trying to push towards that direction, but I don't know how far we've gotten that way because there's still a lot of gas vehicles on the road. Now, can you use this technology for batteries in gas-driven cars?
You wouldn't need to. They're very small and they have a different type of chemical technology. They don't use lithium, which means they don't get extremely hot. Obviously, your petrol tank can, and they do but they tend to have problems with accidents because people have designed petrol tanks for a long time. So it's not the same issue. And again, you could possibly do it in smaller scooters, electric scooters. But push bikes, electric push bikes have the problem, but they're small, and most other X-ray machines can do it. As Hans said, is that ours is extremely big. The first version will take the packs, but the next version we will come out within a couple of years' time. We'll drive your vehicle into our machine.
Okay.
You'll obviously get out, you'll take the X-ray, and you'll drive it back out again, all within a space of 5 minutes. And we won't remove the pack; it will be still part of the car.
Yeah, I was looking on your website, and it kind of almost looks like a mini car wash, right?
Absolutely.
Exactly.
I mean, it's a large building, but I mean, it's not quite as large as a car wash. But that's kind of, I was like, oh, it looks like a little mini car wash. So that's great. So let's talk about how you're using is it doing a simultaneous X-ray and a CAT scan of the car?
Well, what you do is first you start with doing an X-ray that can tell you quite a bit. But the idea is that you need more information than that, because these batteries are quite thick and you want to see something of their inside. Ideally, you would do a full CT scan of it, but that is really very large machine, a lot of data. So we're looking at in-betweens, like the tomosynthesis that we have in breast cancer imaging, where you do a limited swing and still get 3D information out of it. And that will tell you not just what's on the outside, but also what's happening on the inside of the batteries.
And maybe it's also worth saying that we're going to build the world's largest database, a cloud database of all this, while all of our customers' scans will be stored in one place, so that the diagnosis will be completely automatic and very, very quick. And we will also make sure that we support every type of future battery technologies, because this is something that the industry is really busy with. There's a lot of money invested in improving manufacturing technology, because batteries are so sensitive and batteries are so crucial for to solve today's energy crisis and to make the world greener. So there's a lot of money invested in that. But then, so we are going to be ready to provide the same answer for those future technologies, and to offer diagnosis for them as well. And also, we might be able to offer a very important tool for the cell producers, for the battery companies, because we are going to give them a new perspective. They never had access to imaging produced on their cells after 5, 6, 7, 8 years on the road. So they might be able to recognize new patterns. And this is we find this very important and very valuable.
And now in doing the scanning, obviously you said that you're using, CT and X-ray, but is there anything that you're using, to help enhance the images for reading? And that leads me to another question. Who's doing the reading of the images to look at the cracks, see if there's cracks and stuff? Because, I mean, obviously it's not going to be a radiologist, but there has to be, I'm sure, like a technologist, on staff, right?
We're very lucky, because unlike the human body, every single battery is exactly the same. It's only the defects that are wrong, whereas people's hearts are in different places, people's lungs are slightly different. So we're starting from a cleaner template that we're using. Of course, is we could have one battery from one manufacturer. Everything else from then on, we'll baseline it. So machine learning and AI will be really good for us, because we're just going to spot the differences. And once we've learned those differences, all we have to do is analyze how important those differences are. So sorry, Hans.
Yeah, so we're building algorithms to do this for us, and we already have existing collaborations with partners, for instance, who help us do images of bad batteries, well, not just the good ones, but also the bad ones. So we know what they're like, and we can train our classifiers to determine the good ones from the bad ones. Having said that, of course, there will always be some kind of an optical inspection, because you want to figure out what's happening there, and especially if you're looking at results for accidents, then sometimes the human eye is so much better than what's happening there than the algorithm. But if you look at 9,000 batteries and we find out if there's a bad one, this is where the algorithms help. This is where they can do it.
And it's also important to say that existing imaging solutions that can do that today, the ones that we know of are they're more research oriented and very, very expensive, very big equipment artifacts. So it's we're the only ones trying to make it really a commodity, to make it a commercial offering that can provide a solution and help this industry grow and scale.
So speaking of that, what is your hope for this? Is like, I guess maybe I should say your vision for the scanning places? Do you like look at it as, I'm thinking in my mind, this is what I'm envisioning, is that, you know, for like, say, like used car dealerships, like you had said, like someone goes to buy a used like 5-year-old like EV car, you know, that a used car dealership would have something like this on site, and, you know, any type of electric vehicles that come through, they can be scanned automatically. Or are you looking to have like central locations where people can just drive up and have their cars checked? Like, what's your
all of those, all of those.
Exactly.
Yeah, the one that we started some base conversations is the car rental companies. You know, they're not pushing out electric vehicles as often as they can. If I was hiring an electrical vehicle with some children or grandchildren in the back, you know, and I had a green light or red light instead of a green light, I'll swap cars. You know, the last thing I want to do is put children in the back of a car, electric vehicle that might catch fire. You know, and that it just hurts. I said pick on Hertz up, pick any rental company. It'd be a great asset for them if they could do it. And we do believe our scans, once everything's running and the technology's proven, will take about 5 minutes. You know, similar to a human CT scan. You know, they don't take long. There's a bit of preparation, but you know, the scan itself is not horrendous nowadays.
And it's also, so it's a combination, again, as we said, it's all of those that we said, that you just said, but it's also, we're helping to create a new standard, a new safety standard in the world, because it's there's no reason that every used battery, whether it's inside the car or outside of the car for different uses, will be scanned before you take a decision whether you can use it or not. So it's
So, sorry, I think one of the things that really important to a lot of people, especially around Europe, is if you don't scan those batteries, your default position is to throw them in the rubbish bin and recycle them. Okay, it's good that you can recycle the copper and the nickel and all the cobalt, but wouldn't it be better to reuse it and continue using it? I mean, that must save millions of, and it's just so eco-friendly just reusing it, especially if it's capable of being reused somewhere.
Yeah, the carbon footprint is huge.
Yeah,
we keep sourcing lithium all the time. Yeah, it's just crazy. Because,
again, my mind's spinning and thinking about things. So in the United States, you know, we have to have our cars inspected every year to make sure that it's safe to be driven. Is that similar? I'm assuming that you are like that. How now? I'm thinking I'm like, maybe this could be incorporated into part of the inspection, that if you have an electric vehicle, this is part of the inspection, that you have to take it to a location for it to be scanned.
Sure. And we're definitely 100%, but we're not waiting for that to happen. We know sometimes regulators take their time. So we built our business case on the commercial, the free market and on demand. But we definitely believe that the regulator will follow, and insurance will as well. If you have a Tesla, maybe you'll get a discount on your premium if you scan your car. It would be an incentive for the insurers to actually collaborate and to incentivize that.
Mm-hmm. Yeah, that's great. And especially like you said, reducing the carbon footprint and being able to recycle it. So would batteries like that be sent back to the original manufacturer for them to be melted down and reused, or?
There are specific companies for that. They just have specific locations, and they get used packs and then recycle them and sell back the raw material to the producers of cell. So in some cases it has to do with, it's the same one, but it doesn't necessarily have to be. It really depends, because you're trying to save a lot of transportation also. So you don't want to send a used bag all across the world for it to be recycled. You prefer to do it locally, whenever it's possible.
But don't lose sight of the fact that we think if you were to scan those packs and find them not to be as bad as you think, then the second life, connected to your fridge, your TV, that has more value or more worth, and keeps that battery in useful life for another 15 years. Because my TV and my fridge don't take half the power a car requires.
Right.
Mm-hmm. It's also important to mention that we're already scanning packs. So we have a partnership with one of the leading research institutions in the world, that's Fraunhofer in Germany. And we already started doing scanning projects for interested parties. So if automakers or cell producers or any energy storage builder is really curious to see for the first time how it looks inside and what's going on, or even scan a recall pack, then we're very happy to collaborate. We can already do it within our beta version service.
So you guys obviously have an awesome technology on your hands that you've developed, and it sounds extremely useful. I don't really think I have never heard of the, electric vehicles imploding like that, but it's extremely interesting and obviously not out of the realm. It's just not something, I guess, because I don't own one, have never possibly thought of it. But speaking of that, in your journey of starting up this company, have you met any resistance or challenges or even competitions along your way?
Well, there's something that I think your audience will probably understand. How switches do you do if I'm talking? Could you turn it? So, just not we realize. No, so what we have to stress often is that there's the difference between what the BMS in the car is doing and what we're doing now. And the medical analogy here is quite strong. The BMS in your car, the battery management system, it's like what they are. They connect you to all these machines that will tell you your heartbeat, your saturation, your blood pressure. It can tell you very well what it's doing right now. It can predict to some extent these days that whether you will have sepsis or not. Same in the car. It can tell you how you're doing right now. And it can tell you, oh, now the pressure is going up or the temperature's going up. Get out of the car now. It will tell you in time, probably. That's great. But it can't tell you whether you have cancer, whether you have appendicitis, whether you have whatever. There you need imaging because you're looking for something very localized in a specific space where there is change. That's what we can do with our X-ray imaging. That's where we are complementing what electrical measurements can do, what a BMS can do. So that, I think, the essential difference that you're making, and that's why you want us as well as the electrical measurements.
Anyone have anything to add to that?
We fully agree on that.
It's really, it's amazing that as a healthcare professional that sometimes your mind doesn't move outside of healthcare and how, radiology can be used in other facets that, sometimes I feel like we have blinders, at least I should just speak for myself, that you're just thinking about the body, but how useful it can be in everyday life. How Inner is scanning for electric vehicles. There was, I've spoken to another company that scans for lithium batteries, and then another German-based company that does scanning for like overall cast models. So it's just really brightens, at least my eyes, I should say. I'm not going to speak for everyone in healthcare, but how useful the technology can be used in everyday life.
Yeah. You interviewed Glimpse also, which we love. They're doing a great job. And so it's a fascinating world.
Mm-hmm. Mm-hmm. So everybody, this is Efrat, Hans, and Mark joining me, talking about their revolutionized company Inner and things that they're doing with the electrical vehicle world out there. So thank you guys so much for taking the time to be with me and to explain this great work that you're doing for the world overall. I really appreciate it.
Thank you.
Yeah, thank you very much for your time.
Thank you so much.
Thank you. Yeah.
All right, everybody. We'll catch you next week. Check us out on YouTube, Spotify, and Apple Podcasts. We'll see you later. You've been watching The Skeleton Crew, brought to you by xraytech.org. On the next episode, join us to explore the present and the future of the rad tech career in the field of radiology.